welcome to my talk, 3 important data points for every request and every message. My name is Jörg Pfründer, and I work for Europace, which is Germany's biggest mortgage loan marketplace. In this talk, I will show you 3 data points, 3 kinds of metadata that we put into every HTTP request header and every message header. It's trace ID for handling tracing and logging. It's the features for handling feature flippers. And it's the JOT token for authentication. So here we go. Have you ever seen something like this? In my opinion, this is the most annoying thing in computer software, at least for the user. It basically says, we've messed it up, deal with it. And users, usually they cannot handle it. They are just left alone like a small child out there in the dark, crying. I know we cannot write software without errors, but we could do error handling better. This is how an error message looks like in Europace. First, it says there's an error. Then it says, what have you done? What did not work out? And then it says, send us an email that we can fix the error for you. And when the user clicks on the email link, his email client opens up, and here you will have the trace ID. The trace ID is randomly generated in our JavaScript code, and each AJAX call gets its own trace ID. When our web application receives the trace ID, it puts it into every log statement that is written to the log file. And sometimes our web application cannot answer the user's request on its own. Then it might send another HTTP request to another web application, and then it will put the trace ID into the HTTP header again. So every service gets the trace ID, which was caused by the user's AJAX request. When we get a message like that, we jump to our log aggregation tool that collects all the log files from all the services, and then we just search for the trace ID, and we see all the logs that are related to this user's request. Sometimes we see, oh, there's a Java stack trace. Maybe that's easy to fix. We fix the bug, ship the new release, and tell the users try again in a few minutes. And then we have a happy customer. Sometimes it's not so easy. Maybe we can find a workaround and fix the bug later. So that's the first data point. It's the trace ID for tracing and logging. Now for the second data point, features. When we started to use continuous deployment about 7 years ago, people always asked us, how do you handle feature branches? And we said, we do not use feature branches. We use feature flippers, or some say feature toggles or feature switches, which basically is the same concept. What does it mean? It means we do not define the feature set at compile time, we define it at runtime. In our case, it works like that. All users that have some special privileges, like testers or developers, see this small input field at the bottom left. And then they can decide, I will insert the name of the feature I want to test. So for the next, this content of the input field is written to a cookie and sent to our web application. So in our web application, we could define feature flippers that switch on the features that are still under development, but only visible for some privileged users now. But maybe the user-facing web application doesn't have the feature flipper. We want to have a feature flipper in some backend service there. maybe another calculation or something like that. So we need to put the feature flippers, the features string, into every HTTP request and every message in our message bus. So the features is the next data point that we put in every header of every message and every request. So now the third data point is the JOT token, and we use it for authentication. When we started with our software some years ago, we used the traditional session ID, session handling stuff. User does a login, sends the username and the password to the user management web app, and user management web app creates a session record in the session store. Turns back a session ID, and when the user clicks on the next thing, handles the next action, then the web application gets the session ID, looks, has there been any session related to the session ID and the session store, then the user is authenticated and things go on. Now, this works fine with only a few web apps. But we're going to go to microservices, and we will have dozens of microservices, maybe hundreds, and you're not supposed to do microservices like that. You should not have a central database that is accessible to all services. So we have looked for another more decentralized solution. And we found JOT, JSON Web Token. People say JOT token. And it's basically a bunch of encoded and digitally signed JSON documents. Let's have a closer look to a JOT token. This is the JOT token. It is not encrypted, it's just encoded. Everyone can decode it and look what is inside, so don't put any secrets inside it. And when you decode it, you get 3 JSON documents. First the header, then the payload, which is the most interesting thing for developers, and then the verify signature. Inside the payload, you will have some attributes, some standard attributes like sub, which means subject. In our case, it's the user's ID, or maybe the exp, which is the expiration date, and some others. But you can add your own custom attributes too. In our case, it's the authorities or the Benutzername. When the user does a login now, it sends its username and password to the user management. User management creates the JOT token and signs the JOT token with its own private key. It returns the JOT token to the browser, and the JOT token is put in the browser's cookies. So when the web app A receives a request from the browser, it takes the JOT token, verifies that it's a real JOT token from our user management with the user management's public key, and it does not need to go to a centralized session store. Then it can verify that the JOT token is not expired yet, or it can get the data from the payload. When web app A needs to call another service, it just adds the JOT token into the header of the request or into the header of the message, and web app C will get the JOT token too. And it can get all the data which is in the payload. So even web app C does not need to go to some centralized session store. This is the last data point. It's the JOT token. But since we have more time, I just add some other things. There are some disadvantages when using JOT tokens. First, the thing, it's not encrypted. It's just encoded, don't put any secrets in it. Then the size is not infinite. It has to fit into an HTTP header, so don't put too much data inside of it. Then think about exchanging the private key and then you have exchanged all the public keys. You have to manage this. And last one I forgot. Thank you very much.
Thank you. So, questions?
Thank you. My question is, how are you dealing with feature flips or feature flags in your code? Because I guess that you have only master, and feature flags are in your code in production. And so, are you dealing them after some time that are valid, or in production on for months? Or how are you dealing with feature flags in your code? Thank you.
Usually, we have a flag that we build it into the application when we start developing the new feature. Then the new feature is deactivated by default. Just the privileged users, when they insert the name of the feature, they get the feature flag. Then we start developing, continue developing, and do some testing. And once we think it is finished, then we deactivate the feature flipper, and then all users get the new feature.
Okay, more questions? If I understood it right, you said that the trace ID or the correlation ID is produced in the client by JavaScript. So what was the rationale about this decision? Why do you do this in the client and not at the server side, at each consumer-facing server call?
We do client-side logging, so we even get the error messages even if the user does not send us an email. So there's the one advantage: the user gets the error message, the trace ID, and can send us an email even if the server does not respond properly.
But how do you have the trace ID in your server if the server is not responding and not taking the message at all? So there's no benefit in having a trace ID that is not reachable the server logs, or is it?
Well, in this case, we have two possibilities. The first thing is the server or something in between responds with a valid status code. Let's say 0, which is sometimes used for this kind of stuff. Then we display, hey, the message hasn't reached us. And then we don't display this kind of message. We just say, fix your internet connection or something like that. Or maybe it has reached us, but not properly, or something in between. And maybe we do not notice it, but we get 5 or 10 emails, then we notice it then.
Yeah, thank you for the talk. How long-living these trace identifiers are? Are they bound to user session?
They are generated on every user's request. So every AJAX call gets a new trace ID. So as long as the request is processed, the trace ID lives. If you have some long-running task, maybe it will live for minutes, but usually it's just a few seconds.
So maybe one more thing about the JET token. So I think one disadvantage also might be that on logout, it's not invalidated, right? So you can remove the JET token for the user on logout, so if the user explicitly logs out, but it won't be invalidated, right?
Yes, this is the fourth disadvantage. You should only issue short-living tokens because you do not have any centralized store. You do not want to have something centralized for invalidation, so you should think about the lifetime of the JET token.
And the other question I wanted to ask, so, I mean, your trace ID looked quite short, actually. If I imagine like a large site with like millions of user requests per day, then these trace IDs need to be quite long, right? or they will be quite short-lived, which makes the HTTP header much longer, of course, and it's also always like a problem with cookies and stuff. So how much traffic do you have on your side?
We don't have much traffic on our side. It's a B2B system. It's not for consumers, at least not yet. And so we have, yes, I think it's about something between 10 and 100,000 users. I don't know exactly. And they don't produce so much traffic. But we have collisions inside the trace ID. Until now, it hasn't done anything. Maybe you will find a trace ID that has been generated a month ago, but in the context, you will find the right log error statement.
Thanks.
So, thanks a lot again. And Markus is next.
Thank you.